If statement, part 5, truth table, also known as machine logic or Boolean logic. In Wikipedia they say a truth table is a mathematical table used in logic. When they say mathematical, they don't mean something like algebra, with the equation and stuff you learn at high school. It's more of university math or scientific math. The Boolean logic is named after George Boole, a mathematician, a self-taught mathematician and philosopher and logician. You can read the Wikipedia entry about him. Anyway, the truth table is basically how the computer thinks, the machine logic. It's not human logic. It's, you can say, simpler than human logic and more finite. Let me show you how it looks like. This is a truth table I designed for this lesson. Let me make it a little bit bigger so you can see it. Okay. So this part is for the variables we will use to check logical operations. It's A on the other side and B on the other side. So let's say here A is true and B is true, T is true, F is false in this table. In this row, A is true because it's T and B is false. The first one is A, the second one is B, as it says at the top. The second column is about the AND operator and all the options that can happen with the AND operator, like if A is true and B is true, if A is true and B is false, if A is false and B is true, and if both of them is false. Basically all the options that can happen with the AND operator. In the previous lesson I've shown you how to actually use this, so you kind of seen it already. If you remember this part, this if, you have an if operation with the AND logical operator. Here we check two booleans that can be true or false. A boolean has only two values. We check if x is bigger than 2 and n smaller than 10. So any side can be true or false, like t1 can be true or false, t2 can be true or false, but the whole argument must return one of the two values, true or false. And it can have many possibilities because of x can be any number, but in this table we will only check for true-false cases to make it simpler to understand. So let's start with the AND. As you can see, when A and B both are true, then A and B is true. If A is true and B is false, then A and B is false. You can say I'm just showing what happens and not explaining the how and why. So surprise, there is no how and why. That's how it works. If you've studied electronics, you would know this, that this is also how it happens, you can say mechanically with currents. So basically that's just how the computer thinks. There's no how or why. If A is true and B is true, so the whole argument will return true. If one side is false, let's say like B is false, like in this case in red, A is true and B is false, so the argument will return false. And if A is false, but B is true, so basically we have false and true, if we're talking about values and not the variable names. False and true, again, false and true will return false. And false will also return false. That's basically how it works like in the example I've shown you. So if x is bigger than 2, but it's not smaller than 10, it needs to be between the range. So if this part is true and this part is false, so the whole argument will return false, basically, as shown in this table. So the last column is about the OR logical operator. It acts differently than the AND. If both sides are true, it's also true. But if, let's say, A is true and B is false, it will return true, as if it was AND, it would return false. So false or true will return true. False or false will return false. An easy way to memorize it is, let's enlarge it so you can see. In the AND part, everything except when both sides are true, all the other options are false. Like true and false is false, false and true is false, false and false is false, only true and true is false. So basically you get true only if both sides are true. In the OR operator, it's the opposite. It will be true almost in any case, except one case where both sides are false. A is false and B is false. That's it, that's how you memorize it. The way I used to memorize the OR is, it's from an example from a Shakespearean play, Hamlet, about this Danish priest called Hamlet. He said, to be or not to be. So this is also a logical statement. You can't be and not be. You must be or not be. To be or not to be. You can't be and not be. So that's basically how I used to memorize it before I used it thousands of time and memorize it naturally. So basically, if in OR either both sides must be true, or at least one side must be true, so the whole argument will be true. In AND, both sides must be true. And I gave here two examples, but let's say in the OR example with the two names, this can be something else, like checking for username and password. So in this case, this won't do, because you want both password and username to match. So let's say for that case we must use an AND operation, right? So if username is equals to the username the user wrote, it will return true because they're equal. And if the password is equals to the password the user wrote, it's also true. So do the login code. If not, do something else, use the else operation. But OR is more flexible. You can have two conditions and only one of them must be true, or both of them can be true for it to be true. And that's basically how the truth table works. In the next lesson, I will show you more complex arguments with multiple OR and AND operations. So you can use, more complex conditions with, let's say, 3 or 4 conditions that are connected with AND and OR operators. And I also created this to show you the truth table in a different way. Not as a table, but as columns of text. So here what we do is we first output AND logical operator, that's the title basically. Here are all the possible outcomes of an AND operation with true and false. So true and true, false and true, true and false, false and false. I created 2 booleans, one named T, short for true, and one F for false. So if we run this, you will see the result of each argument. So basically, true and true equals true, false and true equals false, true and false equals false, false and false equals false. And I used the dashed lines to separate between the 2 columns. The second one is for the OR logical operator. And we have true or true, false or true, etc., etc. Let's see it in the console. True or true equals true. False or true equals true. True or false equals true. And false or false equals false. As I mentioned, in the OR operator, it's only false when both sides are false. And in the AND operator, it's only true when both sides are true. In all the other cases, it's false. And in this way, you see how the Java compiler handles it. When how Java utilizes the truth table. The compiler runs this argument and returns the result, which is true in this case, true and true. And we do this for all the possibilities for both the AND and OR operators. So you can have a look at this and see how the truth table actually work live. As I said, there's not much about the how and why it works. That's how a computer thinks, basically. The machine logic. Our luck is that it's way simpler than human logic, which cannot be simplified as these few lines of code. Let's see. As I said, to use the if statement more effectively, you must memorize it and understand it. For me, I only started learning this probably half a year after I learned programming alone, which is a shame because it's a very, very important part of programming, which I think newcomers must learn as soon as possible. That's why I'm teaching it now and not later. You might not understand it now, and that's okay, that's reasonable. Actually, it's natural. I would be surprised if someone that haven't touched programming in his life would just look at this and say, oh, I understand everything. The way you actually get it is by seeing examples of how it's used. Like these 2 simple examples, but they're not practical examples. In future projects in this course, you will see more practical examples of how AND and OR and ifs are used in general. And then you will start getting it after you see how it works, and after you start writing and using it yourself and modifying it. And that's how you learn it. That's how you also understand it. It's you can't explain programming only in theory. programming is more something that you do than theory itself. So yeah, you can explain until a certain level, but the student must practice himself to really understand and make it his own way of thinking. As human logic is more superior to machine logic, it's much easy to get used to this kind of thinking. And it becomes second nature after a while. So, as I said, do not worry if you don't understand it. I just wanted you to see it, so you can later reference to it, come back and look at it. You don't have to look at this video. I also added this designed truth table to the course final product zip, so you'll have access to it, and we'll be able to reference it. And basically that's it for this lesson. If you don't understand anything or have questions, you may contact me via the Q&A. Yeah, that's it for this lesson.